Welcome to The Explainer. Today, we're unlocking the secrets that make Python feel so, well, Pythonic. We're going to see how you can take your own custom classes from feeling kind of clumsy and disconnected and transform them into brilliant, intuitive parts of the language. So let's start with a problem that I promise you, if you've ever written a class in Python, you've definitely run into. You know the feeling, right? You build your own class, you give it some data, you give it some methods, but then you try to use it with some of Python's most basic built-in functions, and nothing. It just doesn't work. It feels totally isolated from the rest of the language. A plain old class, it does its job of holding data, sure, but it's like a guest at a party who doesn't speak the language. It's there, but it can't really interact with anyone. It doesn't know how to speak Python's native tongue yet. For example, when you try to ask a simple question like, hey, how many items are in you, using the len function, or if you try to print it to get a nice clean summary, Python just throws its hands up and hits you with a type error. Your class is dumb because we haven't given it the instructions it needs to play nice with Python's core features. So how do we fix this? How do we give our class these amazing superpowers? Well, the answer lies in something people sometimes call magic methods. We call them dunder methods. It's just a fun shorthand for double underscore. But here's the secret. They aren't actually magic. They are a super well-defined and powerful part of what's called the Python data model. You can think of them like special hooks that let you plug your own classes directly into the core mechanics of the language itself. By implementing these methods, you're basically teaching your class the secret handshake. You're showing it how to respond to things like the plus and minus operators, functions like len, and even the really basic stuff like for loops or getting an item with square brackets. Okay, let's start the transformation. First up, let's make our custom objects behave like numbers so we can actually do math with them. Imagine you've got a vector class. Maybe it represents a point in space. You create two of these vector objects, and you try to add them together with a simple plus sign. And bam! Python hits you with another type error, basically saying, nope, I have no idea what you mean by add for these things. The solution is actually beautiful in its simplicity. You just implement the _add_dunder method. Inside that method, you get to define exactly what addition means for your objects. You write the logic, and suddenly the plus operator is unlocked. It just works. And this just illustrates the pattern so well. Almost every single operator you can think of in Python has a matching dunder method that you can implement. You want to subtract? That's _sub. Multiply? _mul. You want to check if two of your objects are equal? There's a dunder for that, _eq. It's incredibly consistent. Okay, next up, let's go back and fix that ugly, totally unhelpful print output. We want our objects to be able to tell us what they are in a clear, human-readable way. We've all seen this, right? You make a simple book class, you print an instance of it, and you get this thing, the class name and its memory address, which is useful for, well, almost nothing if you're a person trying to figure out what's going on in your code. So Python gives us two tools to fix this. The first one is _represent, which stands for representation. Its goal is to give you, the developer, an unambiguous string, ideally something you could copy and paste back into your code to recreate that exact object. The second one is _stir, and its goal is to be user-friendly, to give a nice, clean, readable output for the end user. Now here's a fantastic pro tip. There's a smart little hierarchy here. If you ask for the string version of an object and it doesn't have a double _string method defined, Python is smart enough to automatically look for a double _represent method to use as a backup. That's why the golden rule is, if you're only going to define one, always define a useful double _represent. All right, let's get to our final transformation. Let's see how we can make our own custom class behave exactly like a built-in Python container. You know, like a list or a dictionary. Let's say we have a basket class that holds different items. Out of the box, it's just a black box. You can't ask for its length with len of, you can't grab an item out of it using square brackets, and you definitely can't loop over it. It's basically a container with no doors. But we can unlock these features one by one, just by adding the right dunder methods. _len hooks into the len function. _getItem unlocks reading items with square brackets. _setItem unlocks writing items with them. And finally, the big one, _iter, makes our object iterable, which means for loops just magically start working. So as you can see, these methods give you an incredible amount of power to make your classes feel intuitive. But like with any great power, there's some responsibility. And there are some really important rules you need to follow. I love this quote from Stack Overflow. I heard from one guy that you should not use magic methods directly. Well, let me tell you that one guy was absolutely 100% right. The number one rule of dunder methods is this: you almost never, ever call them directly yourself. You should always prefer using the built-in function or syntax. So you use len of object, not object._len_y. It's simple, really. The built-ins are your safety net. They often include extra checks and optimizations behind the scenes that make your code safer, more robust, and frankly, a lot easier for other people to read. As one of the best guides on this topic puts it, with great power comes great responsibility. The whole point of using dunders is to make your code more intuitive, more Pythonic. You want to follow the principle of least surprise, not use them to create weird, obscure behavior that no one will understand. So by understanding the Python data model, you're not just writing clumsy, isolated classes anymore. You're creating objects that feel like they've always been a natural, native part of the language. So really, the only question left is, what superpowers are you going to give your next class?